Good afternoon.
Good afternoon.
Guys, we're going to share in a special moment here. This is my 50th DevCon session. And I've saved the best for 50. There likely won't be a 51 as a result of this, but here's the other thing with you guys. I've got about 65 minutes worth of stuff that I will fit into 59 minutes. You've heard me talk before. It's going to go really fast. What I'm going to make the deal is with you guys is there's a room down the hallway called Engelman Daisy, right down the hall. And if anybody has any questions or wants to talk about all this stuff or geek out, we're going to go right down there. I'm going to spend the whole 30-minute break down there talking with you guys. If you don't have any questions, I might have some bonus content as well. So the deal is, I'm just going to charge through all this content right now and give you as much as I can fire hose all you guys to make sure I get through all of it. Deal? We good?
Yeah.
All right, awesome. So let's go. All right, first of all, I want to share with you guys my journey, my AI journey. This is kind of something that we talk about quite a bit, and I thought it might be interesting because you might recognize where you are on this graph. So first of all, I actually started as a hobbyist, believe it or not, working with machine learning because I was trying to get something in FileMaker to work, which I realized was regression, and it doesn't work in FileMaker. So I figured out I could accomplish that through machine learning. That led me to actually write a paper, believe it or not, on machine learning with our data scientist at iSolutions here, Dr. Shuckers. He and I wrote a paper back in 2013 on machine learning and fantasy sports. But it got me this gig. I ended up working with the NFL for a couple of years. There's some Cris Ippolite trivia, right? As an analytics expert. But, you know, not much of an expert, and maybe I didn't use my real name. But what I thought about was, but what occurred to me was, hey, this is a cool hobby. It's fun to kind of nerd out on this stuff. But boy, I should really look at how we can apply this for business, right? So that led me looking back into the FileMaker platform. And around 2017, we got CoreML, right? You heard Ronnie talk about CoreML this morning. Mm-hmm. You guys got to re-explore CoreML. It's still there waiting for you. One of the things that I realized was I'm creating all these custom models, but then after a while, I started to see these repeated use cases, like sentiment analysis or summarization or keyword extraction or classification. And then I realized that, whoa, there's a bunch of these models up on the web. I don't have to run these things locally. I can connect to these through APIs. So that really opened up my eyes to making API calls to models. So I started finding all these pre-trained models out there, and then, oh my goodness, in 2020, I don't know how this happened, somehow I got one of the first beta keys for connecting to GPT-3 in December 2020. And I freaked out for a little while, honestly, and I tried to make sense of this, but everything changed. And so what that led to was us spinning up a division over at iSolutions, creating AI integrations for our customers, and I'm proud to say that we've been actively deploying these ever since. And guess what? I'm going to share all these with you so you get to see what people are doing with these things out in the wild. So the other thing I want to mention, because this is important, I consider myself as well versed in the risks associated with AI as I am in the capabilities. And I take the risks extremely seriously. And all the deployments that I'm going to be discussing and showing you guys today have mitigation strategies employed. We are not being reckless with this. And I think it's really important that we all look at it that way. All right, so before we get started, ChatGPT. Why am I talking about ChatGPT? Because I'm not going to talk about ChatGPT today. But there's a couple of points, and I'm not disparaging it. There's just a couple of points that I think are really important. First of all, if you take anything away from this session, AI is not a database. Okay, I'm going to quote one of my colleagues, and he's going to love this. It's not what AI knows, it's what AI can do. And I'm going to show you guys a bunch of stuff about what AI can do. So I promise you after you see this, you'll see what I'm talking about. So just because I'm not bagging on ChatGPT, I want to tell you, I literally spend all day in these things. Like, people are just sick of me talking about this stuff, and you will be in about it for 55 minutes as well. I absolutely implore you to at least use whatever it is, Claude or Bard or ChatGPT. Get this as part of your life. Understand what it can do, understand what it can't do. Have some sort of relationship with AI, because at least that gives you some footing to actually work with. So I'm definitely not here disparaging it. What I'm talking about is business use cases and deployments. In those cases, you should never put your business data into one of these tools. There's a product out there called ChatGPT Team, which says it's secure, which is fine, but you can't integrate that into your system. The way you integrate these models into your system is using APIs. Another takeaway. All we're doing are making API calls to make all the functionality that I'm showing you here today. Okay? So get a relationship with AI, and then when you want to do business deployments, use APIs. So a couple of things about the demos that I'm showing you. Doesn't use ChatGPT. The only reason I say that is because sometimes I share some stuff that we're doing at work with my friends and family, and they go, wow, you got ChatGPT to do that, dude? That's cool. And I'm like, no, I didn't use ChatGPT to do this. But anyways, you can kind of figure out what the, how you can actually make these things work. Now, keep in mind, everything that I'm going to show you are done through secure API calls, and they're done through several different models. So you're going to see some examples of GPT-3, 3.5, 4, but also Falcon, Mistral, Llama 2, and different derivatives. Those are open source models. And that's really important because if you really care about security, you can actually have the models run behind your wall. So none of your data ever leaves. None of these API calls actually has to go out into the wild. The other part is that everything I'm showing you, you can do with FileMaker right now. Actually, you could have done it like 3 years ago. Some of these are pretty old at this point. So there's nothing for you to wait for. There's no reason to be waiting around for the new models or the new features or whatever. You can do all of this right now. Very important takeaway. And in a lot of these cases, we're not married to a certain model. Because these are API calls, you can swap these models out in the back, or you can even pair these together. A couple of these demonstrations started off with like OpenAI, and then when open source models became available to us, our clients wanted to move into a more secure environment, so we brought those inside their stack. So you can swap these out, you can whatever. It's just a matter of making API calls. So that's really an important takeaway here. So really the biggest one is for those concerned about data privacy and security, open source models are your answer. Okay, just something for you to be able to figure out. And again, did I mention all of this is available today? You can do all of this stuff right now on your own laptops. Good. All right, so really the message that I want to start off with. So what I'm going to do is I'm going to do some teaching you guys some of the concepts of AI so that I can show you the demonstrations. We're going to do a bunch of cool showcase stuff, and I promise you we're going to have some fun. Matter of fact, it's going to be awesome. I can't wait till we get to that part. But I want to fill in some blanks on what you're actually looking at before we get there. So the main way that I want to look at this is a terminology that I use all the time when I'm talking about AI, controlling truth. So what do I mean by that? Well, there's a bit of a myth that I want to dispel, and that is language models are not supposed to be question answer machines. These aren't magic 8 balls on steroids. That's not what their goal is. So and the reason I say that is because of the concept of hallucinations. All right, we're going to discuss how we can control truth and avoid hallucinations, which, by the way, are producing false information and presenting it as fact. And I know you've heard that because dictionary.com's word of the year in 2023, hallucinations. Great. So it sounds like a very good pub. I'm going to show you that that responsibility lies on us and our data, and there's some really cool things that you can do with that. So the way that you do this is you supply the answer to your questions along with as much instruction and context as possible when you're making these API calls. This is how you make your language models an expert. And it gives you significantly more control over outputs and allows for governance. All right, so how do we do that? The first thing I want to talk to you about is how we send our API calls over. Ronnie talked about some of this this morning, did a great job on that. This is what we refer to as a prompt template. Is actually made up of a bunch of different things. Only one little tiny part is the actual input command or the question that you're asking or the command that you're presenting in the API call. And what we're talking about here, and by the way, this is a tool that you can use to prime the model for truth. Now, what is this thing that we're looking over here? Well, this is actually all the data that goes into your curl request. When you're in insert from URL and you open up the calculation dialog, this much data gets sent out there. This is all your JSON payload, and this becomes your post request body. So for the rest of these slides where I'm talking about prompt templates, we're talking about sending all this data over. And I'm going to talk to you about how much data we can send over and what some of the constraints are and how memory works there in a second too. But just to put it into FileMaker perspective, all this stuff that we're compiling is the data that we're sending over to the API. And also, you see the word context on the bottom there? That means something real different to us FileMaker folks, doesn't it? So for about 50 minutes, forget what you know about context because it means something totally different in the AI world. And I'm going to spend a whole section talking to you guys about context and how we get context into these API calls. Cool? All right. So let's start at the top with user personas. So user personas, you may have heard like these system prompts that say like, you are a helpful assistant. This goes way beyond that, right? So if that makes sense to you, that you're priming the model for telling it what it does, we can actually tell it who you are and what your goals are. So creating personas, if you do like user stories, this is the same kind of work that you do. It's really critical to know who is interacting with the models and what their goals are for these interactions. So you have complete control over what you're getting back. And one of the ways you do it is define who's asking you questions. So what we do, this is actually one of our processes. This is an actual, thank you to our client here who's in the front row. This is one of our personas that we actually developed. And you'll notice that it kind of breaks down into, we name the persona on the top, kind of like setting a variable. This way we can refer to the persona later in our prompt template if we need to. And then we do a role definition where we actually say, well, what is it that you're trying to do? What are your goals with this data? The data utilization, what data do you need access to be able to achieve these goals? And then kind of an innovation that I guess I don't know if we came up with it, but this is something that we do. We actually interview the people, much like you would when you're doing your user stories. We go through this technique where we ask them, what are 5 questions you would ask of this data? Then we go one step further and say, why? What is the purpose of you asking that question? And we find that we get really good results from the language model when we spend time doing that. Now, sometimes, this part's a little bit optional, but I thought it was worth mentioning. It's the exact same concept of a persona, but in this particular case, what we found out was we were building a system for a user who was going to extract some analysis from their data, but the audience wasn't the user. They were actually compiling it for their customer. So we had to make sure that the insights made sense to their customer. So sometimes you want to define who the user is, what they need to get out of it, and then who the person who's going to consume the data is as well. Now, here's a big one. A lot of what I'm going to talk about a little bit later on is how we get data and bring data into those API calls. But this is a really important part. It's more than just feeding your schema over. It's about the role that the data plays in the language model integration, not the role that your database plays. Like in your database, these fields could have a whole different role than they do in your language model integration. So what you're doing is by defining this stuff, you're going to take the burden off the language model to make sense of your data. Instead, just tell it how to use this data. So what you're seeing here is actually, and this can be a lot of work, I'm not going to lie to you. This is an instruction that I wrote here for one of our API calls I'll show you later on. This is literally one field. But what I did was I took the time to describe, I named the field. It could be different than the name that you use in your application. But I described it in the context of what I needed to do with this API or with this AI integration. And then I even go into talking about instructions. Well, when you're comparing it to different pieces of data, then this one wins over that one, and so on and so on. And sometimes even display instructions, which will tell us how to display it in things like Markdown. I'm going to show you an example of what this looks like in a little bit. So really important to feed the data, but super important to define it independently of how it's being used in your database, but for the purposes of your integration. Okay, Ronnie did a really good job about talking about single shot, few shots. That's going to mean something different later on, right? You party animals. We're talking about, this is an AI terminology. Shots are sort of examples that you're providing, right? So I love Ronnie's term where he says, if you define these and put these into your API call, you're leading by example. There's one, right? I get 2 freebies. Okay. So what I'm doing in this case, this is actually an insight that we want to get out of the system. Now, this isn't the exact insight. We're just establishing a pattern, sort of a length or a tone. And what we do to come up with these is we'll literally interview. I'm going to show you an example of a copywriting system. And what we do is we sit with like the best human copywriter and say, what's the greatest thing you ever wrote? And then we go, okay, language model, do your best at accomplishing that. This is referred to as single shot because there's only one example that I'm providing. Few shot is more than one, basically. There's 0, there's single, and there's few. In this case, this is actually an example I'll show you in a second. This is 5 different examples of what we're trying to get the formatting to look like. Like I was really wrestling with prompt templates with this one, and it just wasn't giving me the format until finally I just said, no, like this. This is what I want it to look like. And I established a pattern. And with these, what I was trying to do is get the all caps and the colon and then like one sentence after it. The second I gave it these examples, it not only gave me what I wanted, but it did so consistently. So you can do that for pattern and style or content or whatever your goals are. And yes, that question that you ask, what products in our line maybe in high, we still have a place for that. We'll refer to that as input or a command. We're not always chatting, right? Sometimes we're just giving a command. So this is where we would call the question, the user question, or the command. That actually goes in there as well too. Another thing you heard earlier this morning were constraints. This is where we're telling it the things we don't want it to do. Now, the interesting thing about this is this comes from testing. Like once you kind of get into the weeds on this, you'll work so hard trying to get things to work that you'll know the stuff you don't want it to do. And this literally becomes your list of things that you want it not to do. And it's just as responsive to what not to do, or while not, than it is to the stuff that you want it to do. All right, so this one's a little bit different, but I think this is a cool story. So I'm going to take you guys through a use case for a client of ours. So what the goal is here is that they're going to create product descriptions out of their system. These guys have like 1 million SKUs. So it's a lot of product descriptions, and they want to be able to do this at scale. So AI does a good job of that. So we're having some luck. We're moving down the path on this project, and then the marketing folks say, hey, this is cool that you got robots doing this, but we need to make sure that they're consistent with our brand voice guidelines and with our copy style guidelines. And so we said, yeah, cool. Give us those guidelines. Give us those documents. So we literally got these documents. Now, this particular document that you're seeing here was 9,500 tokens in length. What am I talking about with tokens? Well, let me pause for a moment and talk about what this means. A token isn't a word, like a word count. I like to think of it like a syllable of a word. And that's because some words are really long and some are really short, so they really break this up into tokens. This is also how you get charged, by the way, for your API calls, unless you're using an open source model. So back then when we were first doing this, we only had 8,000 tokens to work with. That document alone, you saw that big API call we're trying to cram all that data into, that document alone was 9,500 at first. So why does that matter? Well, it has memory in these windows. So it'll stop evaluating. Like you hear a lot of people say, oh, you can like upload a whole book or a 50-page document and then you can ask questions of it. Consider that how much memory or how much access or how much data it can store that you can then converse with or provide, extract insights from. So as long as you stay within these parameters, you're good. So back then when we did this, it was 8K, but here's why I wanted to put this together. Just back in November, we're up to 200K now in these, even more actually in some of these. That is, in case you're wondering on the math, over 9,000% increase in token windows. I say that because I suspect that this probably won't be a problem too much longer. And to give you some perspective on what that might mean, we have a client out in California who's a law firm who came to us and said, I want to send the entire court reporter transcripts of our trial into AI, and I want to ask it any question I can possibly ask. What did this guy say then? When did she do this? Or when did they do that? The problem is, I said, yeah, send me over your last 3-week trial. It was 850,000 tokens. So I go, call me next fall. We'll see how this goes. So that's just the kind of thing you can do with it, right? So I want all of that. So when we get 1 million tokens, those are the kind of things you can do. So how do we do this? I actually took that document and through some AI processes, I told it things like, do this in a lossless manner or condense this and get rid of noise, put it into a structure that a language model can consume properly. After doing all that, I got this 9,500 token document down to about 3,200 tokens. So the whole document fits right inside that call that I'm making. And so what that means, and sometimes you do this in a couple different API calls. I'm going to show you what I mean in a second, but sometimes you can have it write like product description, let's say, then send it over to the guidelines for edit. In this case, we're able to cram the whole thing into to get the edit in the first place. Well, marketing's happy, but guess who got a little worried? Legal, right? So they said the same thing. Hey, we got some concerns. It's cool that you got robots doing these product descriptions, but we want to make sure we're not getting ourselves to any exposure here. So we said, great, what kind of documents do you give humans who are writing these to use as guidelines? And they gave us all the documents. What was kind of cool about this, though, in this case, this would be a separate API call. We get the product description back. You send another call over with these legal guidelines to say, does this check out? Right? So that now my token window is reset. Kind of an important way to think about this. You're not trying to do all of this in one API call. But what's also cool about this is that we knew that humans were going to actually be reviewing this. We weren't relying on the AI to say, I couldn't really sleep at night if it was up to me to say, the AI says it's cool, so ship it. So what we actually, I'll get there. So instead what we do, since we knew humans were going to be reviewing this is what the output of the prompt template that we wrote was. We actually came up with this way to say a risk level 1 through 5, so we could let them determine which ones they want to route for human review. So they say risk level 3 and above or something like that. And so the language model, based on the legal guidelines that were provided to us, actually determine, first of all, isolate, see 100% destructible, protect you from any impact no matter how severe. It isolated those and goes, maybe say highly durable instead, or offer excellent protection. So we could make those edits, but we wanted to keep the humans in the process instead. So in knowing that we're keeping the humans in the process, we also wanted to give them a little legal tip. You can extract that right from the legal guidelines so that they have all the guidance that they need. So now we're going to talk about context. That was that little thing at the bottom. This is where we actually take data and send it along with the prompt template and all the instruction. This is the number one way that you control truth. You literally send the answer along with your question, is the best way to think of it. It's as simple as that. I'm going to really dig in on context and how we have tons of control over this. But what I wanted to do first is say, in the demo I'm about to show you, this one was built originally in FileMaker, and I'm going to show you the FileMaker demo. And all we had to do, because think about it, those the curl request is a calculation window, right? And so we can make references to fields. So imagine this is a let statement where you're just saying let product identifiers equal this actual field. And so what we're doing is we're not having the language model go find all this information about a product. We're sending all the information we possibly could over about the product. Then what the AI does is condense it down, follow all our rules, and then create something based on it. So I'm not leaving it, and in this case, in this company, they probably have a ton of product information in the web corpus, and therefore it could write a description, but we want to have more control over that. So this is what this demo did. So you'll see here, the first API call is we write the different marketplace descriptions. The second API call is a sentiment analysis just to make sure everybody's cool. There we go. And then the third one is the early version of the legal check, not the one that I just described to you guys. Yet another API call goes out after this point. Now, keep in mind, we already have the product description, so we have this other API call that happens. Now we're writing bullets. That's where those the format for the few shots came into play. We want to make sure we got that properly. And I'm going to talk a little bit and then we do industries. Here's a bunch of different use cases for industries. Language model did an amazing job with that, especially with all the context we sent over. Now this one I'll get into in a little bit. This is where we're doing related products, not through relationships or keys, but through semantic search and matching. I'm going to talk a whole bunch about that in the next section here. So that was kind of a neat feature. Now this one is an API call every time they pick a different industry, and all these SEO keywords get created based on the industry input that they've selected. So just to kind of give you a little spirit of how all this stuff works. Secondly, this one's kind of fun. We call our proposals SOWs, or statement of works. And we were sending one over to a potential client, and we realized, this is a lot of highly technical information. We don't think the reviewers were really going to grasp it. So we made a 60-page product brief in plain English to explain it. And someone said, no one's going to read a 60-page product brief. So we took the entire 60-page document, crammed it into a prompt template, and allowed them to chat with it. So now they can just go, what are we talking about here? What are the tasks involved, or how does the discovery process work, or whatever, and they can have conversations with it. And by the way, it's actually a cool sales technique too, because you can see who's asking questions and what they're asking on the back end as well too, which is kind of fun. Okay, so let's talk about this idea of how language models are not the database that we're asking the question of. So first of all, let's take, for example, we want to ask the question, what is our vacation policy? Meaning the company that I'm working for, what is our vacation policy? If I ask the language model, well, actually, let's ask a bunch of language models. What you're seeing here are 4 different language models. We've got ChatGPT in the upper left, we got Claude over here, we got Bard, and then we got Mistral, which is this open source model. What you're seeing are undesirable responses, because literally all I did was ask the question. You can see the question on the top of them. These 3 are undesirable because they basically got all fine-tuned out, and this response is not useful. This is just a canned response that they went in and did some reinforcement on, and that's what they're basically doing a CYA. This one is a hallucination. This is not the correct answer at all. This is one of the open source models just winging it. So this is what we want to avoid. But now, take a look at this. This is a product that we built for one of our clients that is asking the same question, and this is the perfect answer. This is a correct answer with no hallucinations in it whatsoever. Not only that, but it's cited its source, which is the company's employee handbook. And guess what? This is Mistral. This is that little offender that we saw before that hallucinated, and now we got it acting Perfect. So how do we do that? Well, this is another part of the system where we actually feed it the employee handbook, code of conduct. We allow the users in the system that we created for them to pick the documents that they want to chat over. And then now they can ask the question, and we've got the prompt template providing constraints and guidance to say, only look in these documents for our answer. Language models still playing a role of managing the conversation and speaking English, so to speak. So in this case, we never rely on the knowledge of the model for truth, nor should you. Your goal is to minimize the burden of truth from the language models, and that way you don't need to worry about hallucinations, and that way actually you can use less powerful and actually cheaper, and I mean free, models to be able to do these same things, right? So this process, actually the cheat code here is that we are ensuring we get the correct answers because we provide the answers. It's really that easy. This concept is called retrieval. You're going to hear a lot about that. So just to kind of simply put, we provide the answer along with the question before you even need to send anything to the model. As a matter of fact, I wasn't asking what is the vacation policy of the model. I was asking it of a data source. In this case, this is a vector database. I'm going to get into that in just a minute. But when we get our answers back, we take the answer and our question and we send that to the language model. Hopefully that graphic rings home. This is commonly referred to as retrieval augmented generation. Not my favorite acronym, but it's referred to as RAG. Kind of weird. Now, RAG addresses the problem of model training sets not having the data required to accurately and consistently respond to user requests. So by combining retrieval of current info and various methods that I'll actually describe in a moment, along with the language models, you can obtain more truthful, accurate, grounded results than if you just ask the language model alone. I like to think of this as RAG is to LLMs what open book exam is to students. Kind of a fun way to think about that. So the retrieval process that I'm showing you in this diagram is actually what we used. It's called vector retrieval. And that's what I was showing you in the employee handbook documents. And I'm going to get into that in a second. But first, I want to dig into vectors. Promise you, this is the last part of learning stuff, and then we're getting into looking at cool stuff and having some fun. But this is a really important concept. You've probably heard this quite a bit now. So understanding vectors starts with understanding embeddings. Embeddings are specialized vectors that are learned from data and are used to represent complex features of data. The process of embedding involves using specially trained language models to translate words that us humans speak into numbers that machine learning models speak. But it goes beyond that. A good embedding model captures as many features of a word as possible, and it represents those as numbers. Now, some represent combinations of features, but others represent even really obscure features that us humans can't even detect. That's why we use language models to do these. So let's say, for example, soccer. It has two features. So I have two different numbers that are represented. And they could relate to like sport or ball. Each of these features becomes a new coordinate or column of vectors. Okay, so literally I'm extracting two features. A language model is extracting two features from this word, and it's representing those as numbers. Here's the interesting thing. These actually are coordinates on a graph. Now, I'll show you the graph in a second, and it'll all kind of make sense. But before we get there, we need a lot more than two of these things to really make use of this. Some use cases require that we really properly describe something. So we could have two different vectors. Just think of those as features or attributes of something. Sometimes there are some models that go way higher than this, but there's 4,096 different features you can extract from a single word. My team told me the other day we only use about 300. Thought that was a little bit of a letdown, but 300 features of any word is a big deal, right? So what do you do when you have 4,096 vectors? You know how an XY coordinate goes. You plot it into a certain coordinate. Well, this is what it looks like when you plot them in a multi-dimensional space. So think of this in the back of your mind. This is actually the word soccer. This is a real, actual vector graph. So soccer, see how soccer is close to rugby and it's nowhere near football? I'm not saying anything at all there, but that's meaningful. And I'll get to why that's meaningful because, well, I'll just tell you. The important takeaway here is that similar words are clustered together on this graph. Hopefully that starts to get you thinking about this. These clusterings represent similarity, where words that are plotted near each other are their semantic counterparts. So soccer and rugby are the exact same thing, but they're also not that different from each other. So that distance is really meaningful. I'll get back to this in a second, but keep that graph in the back of your mind. Guess what? It goes further than words. We can do sentences this way. This is really where it gets really cool. Sentence embeddings do work the same way. Phrases with similar vector representations cluster together when plotted. Like, for example, if I say, hello, how are you? Or how are you doing today? Those actually have very similar semantic representation, and therefore their vectors are similar. See how these are kind of similar, but not exactly the same? So just as a little thought experiment, what if we actually said the exact same sentence? Hello, how are you today? And hello, how are you today? They have the exact same vector representation. They would be plotted in the exact same spot on that multi-dimensional graph. They would have no distance between them, right? So the less they have in common, the further away they get on that graph. So the closer the distance, the more features a word or phrase have in common, and calculating these distances is how we mathematically determine how semantically similar words or phrases are to each other. So it's starting to make a little bit more sense. Well, let's talk about some cool things you can do with it. Well, first of all, this is kind of crazy. You got to have the right embedding model, by the way. You have to have a multilingual embedding model to do this. But translations, for example, are very similar. So like if you take the word "this is red" that you see on the top and "esto es rojo," I do not speak Spanish. I'll prove it later. I think I just did, actually. But these are semantically similar. I say 92%, but that was just for our users to review this. It's really 0.92. The exact phrase, "this is red" and "this is red" would be a 1 with this particular algorithm for determining distance. So 0.92 means they're pretty darn close. So if you're just wildly doing translations with AI and you're not doing some sort of scoring mechanism, you have no idea how accurate they are unless you have somebody who speaks that language reviewing every single one of these. The way we actually did this is we do, a couple hundred of these, put them in front of actual Spanish speakers, and they rate them on a 5-star rating. And then we go back and determine which thresholds are acceptable. So we'll say like a 0.85 is an acceptable translation. If we get something lower than that, all you got to do is go back to the AI and say, try again, right? Or feed it the wrong answer and tell it to try again. So this is where it gets crazy. Shout out in the back of the room there to my buddy Ken. So these are actually a different type of embedding model. So definitely, you got to have the right embedding models for the right use case. This is what's called a pair classification model, and this is actually kind of crazy. This is where we can determine similarity between needs and solutions. So doing this experiment for a marketing AI project that we're working on, I took 20,000 statements where a customer was expressing a need for a product or service they had. And then I determined the distance between thousands of other statements where a business was describing a service or product offering that often never had any words in common. And we were able to determine the distance between those. As a matter of fact, this is, so this way you can determine the distance between needs and solutions. This is actually the same way that we pair questions and answers in chatbots. It's the same logic. Hopefully that's all starting to kind of come together as well. Now, this wasn't a customer project. This is just an experiment that I did for myself because I thought, oh, this would be great for job placement. So the same kind of thing with these pair classification embedding models. We actually were able to see that they generalize based on patterns, and they can learn what skills serve various roles. And they account for synonyms. So an example would be a post seeking communication skills could match a resume with excellent written and verbal abilities, even though they never mention the word communication or skills. Kind of perfect for this. And it has also subtle nuances as well, too, like proficiency levels it can pick up on. So it tailors junior versus senior position matching. Ultimately, a semantic matching approach like this could be a more fair and effective approach to finding the right candidates for a job than simple keyword searches, which are prevalent in the world today. Another example, built this for a customer where on the top of the screen, this is a support ticket description that somebody filled in a support ticket. These 5 things are, there's vectorized response templates in their system. And the goal was to try to figure out when some questions come in, can we find their counterpart and just automatically send those responses? So in this case, the response category was determined. You see how it says similarity and it's highlighted there? This one says 1.77. There are different algorithms for determining these. That essentially means 0.77. This one's a 0.76. This is a 0.76. You get the idea. That's the most similar. So after determining the threshold, you can say, yeah, anything that's above, I don't know, 80, whatever it is during testing, we can actually send a templated response to them. Kind of a cool feature for that too, right? Okay. This is kind of an old one, so forgive the fonts on this, but this one goes way back. And I wanted to tell this story because this is an example of a custom React application where we trained embeddings for a customer to create a chatbot that would answer questions about a new medical procedure that incidentally did not exist at the time that the language models were trained. So for sure, all we're going to get is hallucinations, right? So I wanted to bring this up because we had to supply our own truth, and ultimately we landed on retrieval. But first we started with fine tuning. You're going to hear a lot about fine tuning, and I may be a voice that sounds like I'm against fine tuning, but this is our own personal journey with this. We tried to inject truth into a model by doing this fine tuning process where you actually put your truth into the model itself and you get your own copy of it. The problem was, and we scored all of our results like crazy. We had like the score of this question versus that question. And did this fine tuning work? Did the next one work? Ultimately, what we found out was that this was an expensive process and that we really ended up with limited control over the models. And the data requirements that we would need to move the needle on these fine tunings, we just didn't have that data on hand. We needed millions of rows, and we had hundreds of rows. Even tens of thousands of rows once done the trick. So, and incidentally, most of the fine-tuning requirements for like FileMaker applications, what our capacity levels are, we just don't have enough data to move the needle for fine-tuning. Luckily, this is how we discovered retrieval. So instead, what we did is we vectorized documents that explain these procedures. We even asked them for all their training docs that they trained their call center humans on, and we vectorized all those and provided it to the chatbot. So the result is a chat where users can query the vector database to get answers about this previously unknown medical procedure, and then send those answers along with the user's question to the language model. And then what the language model does is manage the human-like conversation with the user. So I'm here to say RAG's a lot easier than fine-tuning, and you get a lot better results from it. Okay, so not only vector databases provide retrieval, also API calls can. This is actually an API that we did. We created this is a dubious distinction, the first ever fantasy sports ChatGPT plugin in GPT. Cool for like the three of you in this room. Thank you. Appreciate it. But actually, I had to write all this description. This was a long weekend. And every one of these is part of our API endpoints. So I was describing for the language model, this was that instruction and data dictionary I was showing you before. This is what you do with this data. And when somebody asks a question, you do this, and this is the relation it happens to the other data. Gave all this instruction over, which allowed us to actually move the needle for truth. But the real takeaway here is it's not just vector databases, but you can also use API calls to go get your truth. So this is what that process actually looks like. I was telling you, I provided how to gather insights and how to actually display it. This happens to be in Markdown. So all of this, none of this data lived inside the corpus, inside the model's training set. As a matter of fact, if you were to ask it who Brock Purdy was, for example, he'd say he's a college player or Mr. Irrelevant instead of a marginally good NFL quarterback. Sorry. Thank you. A little bitter. Whatever. Maybe down the room later we'll talk about that. And behind the scenes, what's interesting is ChatGPT is doing something called function calling to detect certain questions and route it to our appropriate endpoints to find the answer. Another way that you can do retrieval is what our boy Ronnie did this morning. This is actually, well, you showed a little bit of this going behind the scenes. Sorry, this is an old version. Yeah, sorry. But this is a SQL retrieval. You saw Ronnie talk about how he's doing SQL calls. In this case, it was for execute SQL, but you could just straight up query a SQL database or a data store as well too, which are obviously very common. So similar to, so basically the key lesson, this is the takeaway here, is that you have complete control over truth and accuracy by leveraging real-time integrations. If you choose to use models alone to supply the information without these techniques, not only are you not really being responsible with your implementations, but your expectations should be very low about the quality of your outputs. So instead, retrieve current, validated data from APIs or databases to ensure that your responses are precise and reliable and useful to your users. Amen. Amen. Okay, now we're going to have some fun. That's what you guys showed up here for, not all these words and acronyms and stuff like that. So let's talk about other input types. So far, I've just been talking about inputting text. But guess what? You can do other types of inputs. You notice that I mentioned voice and image. I also say video. I'm not going to show you any video. Settle down up here from front. And that's because we don't have that capability yet. But I'm here to tell you, I want you guys to think of me when this actually happens, because it's coming, like this year. And as we were talking with one of our clients at dinner last night, think about use cases for this, because when it comes, you want to be ready for this. And they had some great use cases, by the way, so I'm glad that came up. So let's take a look at how you can integrate voice or images into your AI implementation. So first of all, this is voice input. So beyond text inputs, AI can intake other inputs like voice. This happens to be OpenAI's Whisper model. And for example, it transcribes speech into text queries. It's trained on a large data set of diverse audio, and is also a multitasking model that can perform multilingual speech recognition, speech translation, language identification. There are many options to ingest user voice snippets to translate to API inputs, enabling really cool speech as an interaction mode. For example, you could, come on, audio, even use this as a voice input for your FileMaker AI learning companion.
What's the name of the script step that suppresses alert messages?
Got the right answer there. Good. Or, so that's voice inputs. This was my favorite one of last year, image inputs. This one came out late last year. And there's not only the GPT-4V, which is the vision model, but also some open source derivatives. We used an open source one for this. We built a custom deployment where charts from a client's BI system were ingested into our system using these to create written insights. So we literally evaluate the chart. Now behind the scenes, you could use GPT-4V. In this case, we use Lava, which is a llama derivative that has vision. That's what the V is for. And so our prompt templates, which is what you see on the right-hand side, define who the user is, what they care about, and what data is meaningful for them. We then give it this image, it evaluates the image and comes back with this description, turns the image into text, basically. And the end result is the ability to generate personalized insights from these charts. And we deliver very specific responses tailored to all the different users for each one of the personas that we define. Now, the client, who will join us later, was very happy with this. And said that they were very useful insights. We did an insight, an evaluation, and then suggested next steps for that persona. But here's what's kind of cool. He did a really great job of testing this out and scoring it so we could actually see how useful this was. But then we decided to take another round at the prompts and the instruction, and we got a 40 to 50% increase in the accuracy and error reduction from it. So never stop tweaking those prompts. Okay, another client captures road signs with LiDAR. You know what LiDAR is? It's those like Google map cars. There's probably a bunch cruising around here somewhere. And it notes the signs and their locations. And then it sells that data back to Department of Transportations within their organization. I see you nodding over there. Now, humans were rather slow and expensive to do this because what they're actually doing is looking at all like tons and tons and tons of this footage and video, and with their eyeballs saying, oh, that is one of these G282 signs. You can imagine that would be somewhat inefficient. So our solution to this was to feed all the captured images into GPT-4's vision model. Then we get the text description that comes back, and then we vectorize that. We did the same thing with the original training data. So we took all 400 or so road signs, got a description, vectorized those. Then we took all the LiDAR captured ones, vectorized those, and then we did a semantic search, and we were doing the same kind of pairing. And the matching went through the roof. So basically matches with vector distances or similarity above a certain threshold would be determined to be matches. Same kind of thing, medical supply company leverages AI vision system to analyze x-rays to determine surgery candidates. Now I'm bringing this one up. Well, first of all, it's cool. But secondly, because this is a multimodal open source Lava derivative that was specialized for identifying X-rays. So there's some specialization in some of these open source models. But the goal here was to augment human review. I'm not out here to take jobs. I'm not out here to get rid of humans. In this case, what we were doing is flagging potential use cases that could then later be reviewed by medical staff, not replacing their expertise, but really helping streamline the efficiency of the process. So that, I think, is a really important takeaway here, too. So these are just a really short list of some of the amazing things that you can do with image inputs, which is hopefully this kind of makes you think a little bit about what's possible. All right. You can also output things that are not text. Uh-oh. So you can output voice, for example, images, video, machine learning models, code. You guys want to see some of these? Yes. All right, here we go. So first of all, show of hands, how many of you have taken the Claris Connect micro-certification test? All right, that's about right. So those were me. I did those videos. There were about 32 of them. And what I'm here to reveal for you today is 5 of them were my AI voice that was doing the video. And I know that sounds fun, and I was trying to see if anybody would notice, and I'm guessing nobody did, but it actually solves a very real problem for me. I've been recording training videos for like 20 years, and I used to be able to do 50 of those things a day. Crazy, 50 of those things a day. Now I can actually only do about 12 or so on some days because I have like an actual voice fatigue condition. Nobody I work with believes this is a thing, but actually, if you can imagine this, I did not talk for a whole week. Think about that. Yes. So actually, I still have deadlines though. So I built a voice model. I built several voice models, but I'm really happy with the one that I have right now that captures all my tone and inflections. And I still demonstrate on screen, and I feed all my scripts into the AI for transcription. But now I can produce movies at the volume that I used to, even if I'm having these issues with my voice. There are real problems we can solve with this stuff. Now, my favorite of all the demos. A sports website customer that I used to work for, that I'm not going to say the name of right now because I don't want to get in trouble, has about 11 million subscribers. And they create all sorts of content, articles, podcasts, TV shows. You can imagine all the content that they have available. All of it can be vectorized, okay? They also have APIs so that you can get into their game platform. For those people that have life, this is fantasy football. It's my wife calls it Dungeon Dragons for jocks. Dungeon and Dragons. But this is what's really interesting about this use case. I find this to be really fascinating. Most of all that content that I told you that this organization produces isn't really relevant to any one of their individual subscribers. As a matter of fact, because of the nature of this fantasy game platform, most subscribers only care about 15% of the content they produce. That means that they have to listen to a whole hour-long podcast to get 15 minutes of content, or watch a whole hour-long TV show just to get 15 minutes of content. So, what we proposed was something called custom podcasts. This is a synthetic personalized audio focusing only on the subscriber's players and fantasy team activity. Then the AI generates a custom voiceover analysis from the stats and game situations, only covering what's pertinent to the specific subscriber's lineup and decisions. Then I use GPT-4 with the API embeddings, along with API calls to their game system, to actually create the script that you see on the side. This is just a snippet of it, but I said, feed all that data in and create a 2-minute podcast script. Then I took it one step further, and I sent it to the same model that I use for my own voice, but I played a little trick on my old boss. His name's Marcus Grant. Any of you who don't have a life might know who this guy is. He's sort of the podcast host and the TV guy for this organization that I won't mention, unless you look at the bottom corner of the screen, for those that are at the front. But so I copied Marcus's voice, and he was on this call, and he kind of freaked out a little bit, but we're cool. So this is what it sounds like.
Hey, Chris, welcome back to another episode of Your Personal Fantasy Pod. I'm your host, Marcus Grant, and today we're diving deep into your personalized tight end waiver wire decisions for the upcoming weeks. All right, Chris, you're in a tight spot, and pun intended, and you're looking for a tight end to fill in for the next week or two because you lost Logan Thomas to a 2-week injury.
Sorry.
Let's break down your options.
Okay, but wait, there's more.
Hola, Cris. Bienvenidos de nuevo a otro episodio de Your Personal Fantasy
Right?
Pod. Soy tu anfitrión, Marcus Grant.
So we can do 35 different languages. So what that means is, now think about this. We're talking about personalized content. So Marcus can't manually create 11 million podcasts, but with AI, personalized audio insights are achievable at scale. The tech also enables up to 35 different languages beyond Marcus's abilities. So that means every fantasy football manager can get their own weekly personalized analysis podcast in their preferred language, all powered by AI. No, Marcus does not speak Spanish. So here's another practical use case. This is a client of ours who asked us to translate closed captions and on-screen text from training videos for localization. This is a very common use case. This is a huge cost center for them. So using AI, we were able to extract text from these documents that are called XLIFF documents that come out of the training system, identify the text that needs to be translated, shoot it off to the model for translation, and insert the translated values back into the document. But we took this one step further by converting the translated text into voice audio. It just so happens that each utterance has a little ID next to it, so we're able to actually create little AI voice snippets that we convert into translations, which would sound something like this.
Evaluación de riesgo químico y exposición.
I told you I didn't speak Spanish, but that's the idea. So now the editors, because you don't want one big long, this is what my editor told me, you don't want one big long audio. You want to be able to have the utterances so that you can put them at the different edit points. So dramatically reducing the scale. And the crazy thing is you can take the original person's voice, clone it, and then have them speak in localization in their voice. This is more of a contracts and rights thing, but technology-wise, it's totally doable. Okay, images. What you're looking at is an example of diffusion models. You can generate images from text prompts after being trained on images with a certain style. This isn't the DALL-E 3 type of image thing. What we're actually doing here is using a diffusion technique, which is similar to like stable diffusion, or a model that was actually just announced last week from Google Research called Lumiere. This is actually Lumiere that you're seeing. So this was the input, and then these are all the outputs from the model, sort of derivatives of that image. So how could you use something like this? Well, we use this method to train an image model on years of designs created by humans. That's what you see in the left-hand side there. And then using this model, a customer can then describe their designs in plain English in a natural language and say something like, give me a bunch of people playing by a pool with our Splashberry product. Now, granted, text, for our use case, text doesn't matter. It's getting a lot better, though, by the way. But all those are AI-generated images. So what do you do with something like this if maybe your text isn't that great yet? The model can produce these options using the approach greatly streamlines the process of customers having to submit detailed requests and then human designers beginning from scratch. Instead, the model outputs sketches that can help the ideation process, also spark ideas for further refinement, making the entire process of brainstorming and creation that much more efficient. Similarly, another customer that has animated characters, you see those on the left. So we trained a model with the human-made designs. This enabled generating fresh animated content from text prompts that you see on the right-hand side, even some kind of fun ones where we're able to integrate it with human beings, like running a marathon with a person or something like that, or showing them working from home at their desk. So AI allows custom image outputs based on trained core truth designed by human. All right. AI can also generate synthetic video based on prompts. Yeah. As a holiday gesture, we had some fun internally. Now I'm making it not internal. We mapped my voice, my face, this mug, onto Buddy the Elf, allowing my likeness to act out scenes from the movie. You guys want to see this?
Yes.
All right.
Hey,
So sorry.
what's your name? My name's Buddy. Oh. Does someone need a hug? I just wanted a hug.
Okay, so it's not perfect, but this passed the mom test. I sent this to my mom, and she goes, "Did you perm your hair when you went out to film this video?" So nailed it for mom. She definitely knows what I look like. So now it's a little bit of a silly example, but I want you to think about how this illustrates realistic video generation powered by text descriptions. Think of this instead of a custom podcast as to custom video content on demand in the same manner. So moving along with this, we can also output machine learning outputs. As a matter of fact, in this case, what we did is we combined machine learning models and language models. There are a lot of integrations that combine the two of these things together. They are not the same. That's the first part. In this example, we use a large language model to intelligently extract the items from the product description that a salesperson wrote on the top. That's what creates the initial line items for an estimate. Then we have a separate machine learning model that actually optimizes these line items and says, oh no, actually when these convert to jobs, they should be these. So we're really improving the estimating process significantly. By the way, there was like single digits of correctness when it comes to estimating. I think most estimating, which is really just guessing, are very low factors. So using a machine learning model to leverage this really increases that pretty significantly. So the language model extracts key inputs from text, and then it contributes the input factors that the machine learning model needs to actually run and create its predictions. So they work in unison with each other. Also, AI can even output code based on natural language inputs. Our team here at iSolutions uses these tools on a daily basis. As a matter of fact, I'm really proud to say, I'm an old dude, but I even use these tools to teach myself Python. And I was very proud to submit my first ever competition into the NFL Big Data Bowl last January. And I used 100% Python, and I used my AI assistant to help me learn this and submit. I'm really proud of that. So never stop learning. Speaking of Python, thank you. Speaking of Python, AI can also output executable code like spinning up persistent Python environments to analyze data. Users of these systems can be identified with the sophisticated personas to personalize the responses, like I mentioned before. And while the language models alone cannot be relied on to do even simple math or sophisticated processing or visualizations, we instead use highly sophisticated Python packages and libraries to do that for us. It's kind of like having a data scientist in a box, which our data scientist does not appreciate, but I think it actually resonates quite well. So with Python libraries for visualization and analytics, combining with language models to orchestrate complex workflows, secure and scalable solutions that can have never before seen capabilities. The demo that you're seeing here shows AI execution environment orchestrating data analysis. It makes API calls to ingest data rather than relying on the language model for truth. And then rather than just answering the questions, it actively processes the data, identifying correlations that the API alone could not provide. The environment can even intake new documents and data sources and rerun its analysis accordingly. Then it dynamically visualizes the outputs. Finally, it bundles the visualizations, conversations, and analysis into a downloadable report document. This is what's called an execution environment. Would it be cool if you had your own secure execution environment, like I just showed you, inside your own network? Multi-user persona support, securely connecting to every data source in your organization, all orchestrated by state-of-the-art language models. I'm just saying, that's all I have for you. No, actually, I'm really proud to say that one of the things we've been working on in the lab is exactly that. We're excited that we've got this this environment called Intuition. It's our new AI execution environment that enables secure multi-user data analysis, insights, all safely behind your firewall. No kidding. Brings together professional user personas customized to your teams, our tailored prompts and templates, all created for your unique use cases, cleaned and enriched internal data sources, along with powerful execution environments provided by Python with hundreds of Python data science libraries. This Intuition platform can connect data sources like SQL or FileMaker, external API sources like Shopify or QuickBooks, and orchestrate complex workflows in your preferred language model, whether it be cloud or open source or a cluster of those. It enables chatting with your business data, visualizing, extracting insights, even compiling report documents. Our team handles everything, don't worry about it. From auditing your data to defining the personas and tailoring these prompt templates for accurate, meaningful responses. This environment is also containerized for easy deployment into your cloud or on-prem stack, which we can, of course, help you configure and support. It's optimized and intended to be integrated into existing apps. And it's a custom solution that you own. You can build upon to future-proof your business. These are the kind of things that are possible with AI. And by the way, if you guys want to talk to us down the hall, we're welcoming a couple more pilot customers on this in case anybody's interested. All right, before I leave you guys today, I created something for you. This is a GPT. For those of you that are on ChatGPT Plus, I created a GPT of this entire session. I did a bunch of run-throughs, did transcriptions of it, fed it in as knowledge. So you can go in and ask questions of what I covered here today. I also put my speaker notes in there as well too, and some other supporting documentation. So at your leisure, it's just like having me asking a bunch of questions about this stuff. You can ask this 24/7. You can do the same for that Intuition thing that I just mentioned as well. But what's cool about this is we actually do have some of the functionality. So if you want to try it out yourself and throw some spreadsheets in here, you can kind of see what kind of outputs you can get. All that stuff is going to be found on our isolutionsai.com events page, and also at isolutionsai.com/intuition. And here's the good news. This is what I want to leave you guys with. To really excel in this field, you just need a couple of things. You need to be really close to your data. And you need to be working with organizations that have a custom mindset when it comes to data. Guess what? I just described everyone in this room. You all meet that criteria. It's pretty amazing, right? The other part is, if we're talking about the technical hurdles, you don't need to be a data scientist. You don't even need to understand transformer technology. You don't even need to know the acronyms or anything I just told you earlier today. You just have to know how to make an API call and parse out that response, right? You're closer to being an AI expert than you thought. Now, on that last note, I'm going to head down to Eggleman Daisy Just right down the hall, and I'll stick around through the break to answer any of your questions. I might even have some extra content about AI predictions for 2024. But guys, thanks for being part of my 50th session.